Here we're investigating the relationship between the voltage across and the current through some different materials. In particular, we'll be looking at Ohm's law and materials that follow Ohm's law, like a resistor, and materials that don't necessarily follow Ohm's law, like a light bulb. This would be a non-ohmic material, and a resistor would be ohmic. Of course, some resistors also have a temperature-dependent resistance, such as could be found in a digital thermometer that actually uses that temperature-dependent resistance to measure temperature. Here we have a DC regulated power supply, so we can adjust the voltage between these two terminals with this knob here, and we can limit the current that will flow through the circuit with this knob here. So I have these leads with alligator clips on the end, and I can put them on to the leads of the resistor, and I've created a circuit. Now we can adjust the voltage here, and if we unlimit the current, if you can see this red light being on means that the current's being limited by this switch, this knob here. So if I raise the value, it'll go off, and now the current is just relative proportional to the voltage, with the constant of proportionality being the resistance. Now let's not rely on this display, since we have these nice multimeters here that can measure voltage and resistance more accurately. In order to measure the voltage, I'll use this X-Tech meter, and I'll attach some leads, usually black for negative, so I'll put that into the common port. It even has a black ring around it for convenience. And since I'm measuring voltage, I'll put it on this side where there's the little V for voltage, because the circuits for measuring voltage and current are different on both of these multimeters. Okay, so I have a negative, and then I'll set it to read DC voltage. This is on the 600 volt scale, so if it's showing 0, we'll just have to turn it down to a lower, like a 20 volt scale, in order to actually see the voltage instead of it just being off the screen. But we'll start with it on the 600 volt scale so that we don't blow anything, blow a fuse. Okay, so measuring voltage, we want to measure the voltage across, and try to get this more clear, the circuit element like the resistor. So I'll have the negative go on the negative side of the power supply, and the positive go on the positive side. And so this is not the voltmeter, if you can tell here, it's a little crossed, is parallel to the circuit that we made earlier. So if I turn, I'm using the fine control. If I turn the voltage up here, it should be reflected over here. We're at under 2 volts, so that's not really showing up on the 600 volt scale. So let's turn it down, so you can see that. 1.6, and to get more precision, we can turn it down to the 20 volt scale. Good, so this seems pretty accurate. Now, to measure current, we'll use this multimeter, which is similar, different brand. I'm going to turn it on the current mode over here, which you can see there's an A, and it has this solid line over a dashed line. That's for DC current. And I'm going to turn it to the higher scale, not 200 milliamps, but 10 amps. And then I'll connect the leads to that multimeter, which we're using as an amp meter. Black in the common, red in, whoops, not in the voltage side, but the current side here, 10 amps. Okay, that's what we set it to here, 10 amps. Now current, we can turn it on. Current needs to be measured in series with the circuit. So that means, how can I do this? I think the easiest way, let's turn this down to begin with. So the power supply is off. Basically, it's turned down. And I'll put this, the negative side, to the positive side here, and the positive side of the multimeter into the positive side of the power supply. So now the ammeter is in series with the resistor, right? We're going from positive in the ammeter, the negative side of the ammeter is attached to what was the positive side of the resistor, and then we keep going back to the negative side of the DC power supply. And the voltmeter is still in parallel with that circuit, measuring the voltage across this resistor. Okay, good. Now we can read off the voltage and the current, voltage across the resistor and the current through the resistor as I vary the voltage, and let's make it not current limited, so I'll let the current go up a little bit higher. As we vary the voltage, we can see 5.6 volts, the current is 120 milliamps or 0.12 amps, and so we can adjust there's a fine knob to get a finer adjustment on the voltage so we can get the data points that we want. So for 6 volts across this nominally 47 ohm resistor, you can see here has a yellow stripe, a purple stripe, and a black stripe, and that tells you the resistance in a sort of convoluted color coding scheme. At 6 volts there's 0.13 amps through the resistor, and then we go and we vary the voltage to get our next data point, and we use the fine knob to get right at 5 volts. There, and so at 5 volts for this particular resistor we see 110 milliamps. Now we want to use the same resistor for all our data points because the resistance can be off by, this has a gold band, which means it's a I'd have to check that, 5% tolerance usually, but resistors being off value by 15% is common too for other types of resistors.